Okay, let's get started, gentlemen. I want to introduce Pierre. Pierre is well known to the radio amateur community down here in Victoria. In fact, up and down the island, for that matter of fact. Um, Very active. Uh, Loves HF, of course, but also does all sorts of other very important things for the for the radio amateur society here on the island. Member of Island HF, member of WARA. He's a very involved dude and great sense of humor, both languages. Um, and Pierre knows Brian and myself quite well because of Saturday morning breakfasts, but also Roger because Roger comes out to the coffee get-togethers we have. So it's great to have you with us this evening, Pierre. And maybe you could tell us, just give us a little bit of a biography, if you would. You know, what you did in the Navy. I know you were a diver, but obviously a comms officer and that sort of stuff. Could you give us a little 5-minute bio?
Okay, well, I joined the Navy in 1973, did my basic training in Saint-Jean-d'Iberville in Quebec. From there, I went to Halifax, did my Sea Environmental, and the communications school was out in Victoria. So I came out to Esquimalt, to Esquimalt, because I didn't know how to say it right. And this is where the communications school was at Naden. And I got to see both Halifax and here, and I had a choice. So all of us that wanted to go to stay here in Victoria, we asked for our first posting to be in Halifax. Everybody that wanted to go to Halifax asked for here, and we got what we wanted. So that was 1973. My first ship was HMCS Gatineau. My second ship was HMCS Restigouche. Third ship was Yukon. Then I went to Mackenzie for um, a temporary duty assignment. And I also, my last ship was HMCS Annapolis. So I started out as Northern Air Seaman Radioman. I took technical courses, became a radio operator. Then I became a communications technician C. Then they brought us back as a radio operator again. And my last position was on the Annapolis as the senior radio operator or the POTEL, Petty Officer Telegraphist. So I'm going to talk tonight basically on the Restigouche class. Now, the Restigouche class is a river class destroyer. All the destroyers that we had in Canada were named either after rivers or tribes. So you have tribal class and river class. This happens to be a river class. And in the Restigouche, there were seven ships, including the Chaudière, Columbia, Gatineau, Kootenay, Restigouche, St. Croix, and Terra Nova. So those are all rivers across Canada. Pardon me. Three of those ships, Chaudière, Columbia, and St. Croix, were not um, were not improved. So in the late 60s, they were mothballed. Chaudière became she was decommissioned and became a classroom. No, St. Croix did. Chaudière was used for parts, and Columbia, she was used for parts also because Kootenay had a big collision and they had to replace her whole bow, and they took it off of Columbia. So the four ships that were left were Gatineau, Kootenay, Restigouche, and Terra Nova. In the late 60s, 67, 68, they did destroyer life extension or DELEX. And the big changes I can show you if I can get it here. Okay, this is basically, I don't know if you can see the diagram there. This is how they started with the mast. And as you could see from the first picture, then they put up a gigantic mast that from the tip of the mast right down to the water line was 175 feet compared to about maybe 80 feet. So a big difference. So when you change that, you're changing the superstructure. You're changing, they changed the armament also. They changed the sonar equipment. So it changed all the electronics on board the ship. So basically, I'm going to talk quickly about the HF antennas. We had transmitting and receiving antennas. Okay, we had two port and starboard 35-foot whips up here, and we had one back aft. We had also what is called transmission fans, transmission and fan antennas. Now, these fan antennas were for 2 to 36, 2 to 6 megs auto tune for 3 of the transmitters that we had. If you'll notice in this picture here, you have the transmitting fans and you have the receiving fans. They're at 90-degree opposition to minimize RF interference from one another. So going back to the receiving end, well, let's keep up with transmitting antennas. We had one other one, which is our LF antenna. That went up here and down, stack, and down to there. Now this was for basically the 400 to 500 megacycle range. It was used for a beacon, and also in case we had to answer a ship that was on distress on 500 kilohertz. Oh, 500 kilohertz, yes. 500 kilohertz distress, CW distress. Now, the other, oops, let me see, can I bring this over? Do you see this one now? No, can't see that one, I guess. Okay, we'll continue on here. At the top of the mast, we have a direction finding antenna, which is the SRD 501. And then you have the UPD 501, which are CAN antennas that were used. You could use up to 9 transmitters on VHF, UHF. And basically, the basic thing that you had with those antennas is that you have to have 3 megs separation between transmitters. So we had 9 UHF transmitters that we could use on that. And you only had to have 3 megs separation between them. And we can transmit simultaneously on all 9 transmitters. Don't ask me how it worked, but it worked. Okay, going down, we have the ANSRA 17C. That is an LF probe. It's a receiving antenna. We used that basically for the LF receivers that we had. So I'll show pictures after this of some of the equipment and try to relate to it. So just remember that this antenna was an old, we had a Raycall receiver that had an LF component, and that's the antenna that we used to tune in the radio. And it could be used, as you can see, there's 2 of them, one here and one there. What they could be patched to any receiver that had an LF component through a patch panel. Okay, we had also, where is it? Okay, the AT150 is a hammerhead antenna, which is basically made like a T, and it's for UHF also. It was basically used for one basic radio. There were 2 of them actually in the operations room, and they were called an ARC 552, which is an aircraft radio. It was quick to change the frequencies on it, and they used it for voice communications when we had an aircraft that came on station, and so they could communicate quickly and change frequencies with the aircraft. We have a LoRaN antenna, which was for navigation. We also had an entertainment broadcast antenna. These antennas down here are to do with electronic warfare. So again, so actually the AS1018 was the CAN antenna that did the UHF transceivers, the 9-1. There's the LF probe again, and there are receiving fans. Now, these are port and starboard fans. So you have the same array on the port side and fore and aft. And with the patch panel, we had the capability of either using the two forward antennas, port and starboard as a receiving array, or the two aft ones as another array, or we could use the two port sides as an array and the two starboard side as another array, depending on how we patched them in to a receiver. Oops. Did I just lose everything? Okay, there we go. Sorry about that.
So what sort of things would make you go to the starboard side or to the port side or
Okay.
fore or aft? What would be the things that make those decisions?
Well, the big thing also is depending what frequencies were active in transmitting, but also if we wanted to null one area, right? So if we were listening to a low level signal, we can find out quickly if it was on the port side or starboard side. It
Gotcha.
would help.
Yep.
Now, there's antennas that are not listed that are here. So we had EBR's entertainment broadcast radio. So we had Hallicrafter receivers. We actually had a turntable and an amplifier to broadcast throughout the ship the um, broadcast stations from around the world. So BBC, we could listen on there, and Deutsche Welle, you listen to, for the crowd. Now, the music also went across the whole ship, except there was a muting interruption switch with the public broadcast. So if they wanted to address the ship, the public broadcast would interrupt the entertainment broadcast. So each mess deck and each mess also had one of these boxes that you could choose channel A or B. That's all you had. You had music. So one of them was for the young guys was rock and roll, and the other one was country and western for the old guys. Yeah, so there, the LF transmitting and wire antenna ran between the yard arms aft and the superstructures. Well, that's the one I was showing you over here, this one. Okay, now I'm going to try and see what else. Do I have anything? Okay, this is the communications room itself on the Radio Shack, and I don't know. Okay, so this is the wardroom. Okay, this is the entrance here. Okay, right here is where you came into the Radio Shack. This was the message center where the signalman took care of all the messages. So the officers or whoever brought a message in, they would do the handling and pass it on to us for transmissions. Over here is called Radio 3. That's where we had most of our transmitters. And in here we had the Radio 1, which had one position here and another position there for CW. They had two receivers, two typewriters, and two seating positions that you could copy your Morse or whatever, and all your paperwork that you needed. Over here we had a patch panel and a channel switching unit. This was the boss's desk right there, the petty officer telegraphist. Over here we had teletype equipment, and over here also we had another desk. That's where the person that was in charge of broadcast all the messages that would come in on radio teletype would be copied there. in the back here, we had the cryptographic room. This is where all our cryptographic equipment was, and there was a door that could be locked. So anytime there was any cryptographic equipment opened, the door was locked. So there was only one or two persons in there. Nobody had access to it. Okay, I'm going to stop the share for a second. I'm going to bring another page in. Okay, so share. And the page I want is this one. Okay, so let's bring this one. Share. So here's more of the information that we have. So this is the direction finding one that we used to have. Oh, and I have to say, first of all this material that I'm showing, I have to give credit to one person. His name is Jerry Brock, VE3FAB, Foxtrot Alpha Bravo. He's the one that put all this together and put it on the internet. So I'm just using his stuff to demonstrate. Now these are, now you can see that some of the antennas apply to AORs, Annapolis class, IRE, which is improved Restigouche class, Iroquois, which is a tribal, Mackenzie class is another class, and Saint Laurent was another class, a river class also. Mackenzie, Restigouche, and Saint Laurent class are all river class. So is Annapolis. The Iroquois was the only one of four tribals. There was Iroquois, Athabascan, Algonquin, and Huron. So one of the things I want to go to is these are the receiving antennas. Okay, as you can see, you have glass insulators at the top, and they all feed in to a connection that's inside this structure here that basically is a Bakelite half moon that you have one connection that goes in, and that feeds down through coax into our antenna patch panel. But as you can see at the bottom here, they're all attached to the hull, right? Now, every now and then we had to replace those. Well, an incident that we had back in the late 70s, there was HMCS Terra Nova, HMCS Kootenai, and us, HMCS Restigouche. We're just outside of Mazatlan before going in to Mazatlan. HMCS Terra Nova got hit by HMCS Kootenai while they were doing maneuvers at night, and both of them came in and hit us, and they took all those antennas out. So we had to basically gather them back up on top of here, hold all the wires, make sure that the insulators didn't get broken. The next morning, right when the sun came up, we had to climb over here. One guy with a safety belt on here. One guy was up here, came down on a bosun's chair. Another guy was up here with an electrical cord and a big soldering iron and passed the units down so we can solder them back on. Not fun. Again, going back. So as you can see, this is again, so you had MF, HF receiving antennas. Well, to make a difference, they call them fans. Well, for us to make it simple for all the people, because remember, you had some Frenchies on there, and you didn't want to confuse them. So we call these transmitting, we call these the fans, and at the forward part, we call these a harp. So we know right away, if you're talking about the harps, you're talking receiving, talking fans, you're talking transmitting. Okay.
Could I ask a question?
Sure, go ahead.
Yeah, you referred to the transmitting antennas as 2 to 6 megahertz.
Yeah.
Does that imply that six megahertz was the highest
No, it isn't.
HF transmitting frequency you'd use?
No, I'll go back. I have to go back to this one here. Okay, so let's go back up there. Go back to share again. Sorry. Where was that one? This one. Okay. So this antenna at the back here was a one that could be shared between our three HF ERC 32 transmitters. Now they had an SR, I think it was an SRA 22 was the coupler. And you had to manual tune that antenna. So you could only have one that was above 6 megahertz on that type of transmitters. Now, if I could indulge, I'd like to show you some of the equipment that this was involved with. Okay. Now, which one was it? Was it this one, I think? No, I'll go back to this one and go back this way. And okay, transmitters. Okay. So one of them I'll show you first of all. Okay, this is what we used to call the beast. It's the SRT 502. It has an HF position here, an HF transmitter there. This is the modulation and also the power supply. And over here you had the LF transceiver part. Now, to match the LF transmitter to that wire antenna that we had a coil room in the superstructure. There was a special room that was about, let me see, it's about 10 feet by 10 feet by about 8 feet tall. It was all lined in 1/4-inch copper. And you had the coil in the middle of that with the different taps for each frequency. So you had 4 different taps and through here you could choose which one of them, and you could tune either 420, 425, 500 was one of them, and I think the other one was 415. So the capability of the LF transmitter, I think, was a maximum of 500 watts. The 2 HF was 1,000 watts. The other transmitters that we had, these are the ERC 32s. And a little anecdote with one of those, behind this component here was the master oscillator. And when we went to China in 1983, 3 of ours they just went haywire. So what I had to do is this is where you choose your frequency, and this is part of the amplifying section. I had to put an input from a signal generator in there just to be able to transmit. This is the power supply here. All right. Let's go down some more. That's the coupler section. This is where you tune that antenna that was at the back. Because, where is it? Where is it? This is it here. This is the one antenna that was at the back that permitted us to go above 6 megahertz. And this jack over here was the one to the antenna. You had the 3 transmitters that were there. So you had to take the transmitter and plug it into that antenna. That would let you use this section here to tune it above 6 megahertz. The other ones had an auto tune, same thing as what we have, an auto tuner. Just press the button and the servos would go through it. There's a whole bunch of other stuff here I can go through that don't apply. This is our antenna control. Okay, they don't have. Let's go to some of the receivers. This is our MUFAX, Compliments of England. It's a weather facsimile chart receiver. So you took a receiver and you put the signal through that, and it would actually print weather maps. And you have the paper is wet, and you have a helix inside with a blade that actually turns, and there's the blade that goes across with the signal. It burns the paper to give you the chart. Now, Murray had made that, and before we deployed to the Far East in '83, our blade on the helix had broken, so I had to do an immediate operational requirement to get one of those, and it was in England. There was nowhere in Canada we had spares, so they had to get a commercial flight stopped, get the parts to them, and fly it out to us within 72 hours. So I don't know what the government paid for that, but it wasn't cheap. Okay.
Where were you located at that time?
I was
China?
here in Esquimalt.
Okay.
This is called an R1051 receiver. It's basically a HF receiver. You can have an LF component. As you can see, that probe antenna I was telling you, the SRE-17, could be used with that. This was used for, it had capability of AM, USB, LSB, and I think CW also was capable with it. Yeah, there it is. So it did SSB, AM, CW, and FSK. This was the LF component. Okay, this was the frequency converter. Okay, this was the general purpose receiver. This is made by Raycall. The part on the top is the LF component that lets you, the bottom part was, I think it was 2 to 30 megahertz. This would let you go down to, I think, 10 kilocycles up to 1 meg. The bad thing about this is that they drifted. They're a tube radio and they weren't stable. But you could lock the dials, but still, they would waver. But as you can see, you had 2 handles here. That's so if the ship rocked, you hold on with one handle and you tune. The thing that I really, really liked was they had a bandpass filter over here that you can narrow your bandwidth, different notches, so you could eliminate a lot of QSB. And you had a beat frequency oscillator that you can slope basically your CW signal or your radio teletype signal one side or the other. So that's about all that I have. If you have any other questions, I'd be more than happy to answer them. And if there's interest enough, I can show you the difference with other classes, what they had that we didn't have, and do a little bit of comparisons.
Questions, gentlemen?
Was there a degradation of signal? I noticed that your fan antennas were up considerably higher than your HARP antennas. I realize they were at 90 degrees to each other, but there was a heck of a difference in heights. Was there a degradation in signal on the receiving antenna? Obviously, the transmitter antenna is up higher, and it's going to have a lower takeoff angle.
Let me see if I can get back to that picture again. There's a few things you have to take into account also. Where is it? Okay, where is it? Okay. Now, you can see the picture, or no? Yeah, you see the picture.
You can see the picture.
Okay, now the antennas, as you can see, are right here, right? The fan antenna. Okay, there's the insulators.
Yeah.
Okay. Now, back here, you have an anti-submarine rocket launcher. So you don't want to have anything in the area when this thing tilts and shoots. It's not necessarily on degradation of anything. It's you have to be able to fire this thing. And if you have an antenna that goes too far back or is lower, it could impede how this thing shoots. Now,
No, I understand that, but I was talking about between the transmitting antennas and the receiving antennas.
okay, the receiving antenna is basically oh, there's no different. There's just so much room on that mast, for one thing. And the other reasons that they had them over there is, like I said, we could use them as arrays. That was the big thing. And that's the room that we had. Every inch of that ship has to have a purpose to have it up. And also you can't bring any, you got the radar, so you can't bring anything down forward. Right?
So, Don, ask your question once again. We're not quite getting it. So ask your question once again.
Well, okay, there's a difference in height between the transmitting
Yes.
antenna and the receiving antenna. And I guess the only purpose for the receiving antenna to be down low like that, I get it, they're on both sides, is for nulls. And but I was thinking, height is might, right? So the
No.
receiving antenna would be considerably lower than the transmitting antenna.
When your ground plane is the ocean, height is not necessarily might. Your ground plane is the might.
Okay. And that's why they feed them against the boat.
Yes.
Okay, that's good.
Yeah. And as you can see also, just going back to that beast I told you, these were the two antennas for the beast, the two 35-foot whips, port and starboard. They were dedicated to that transmitter.
And remind me again about the beast as far as its
Okay.
frequency ranges and all that sort of stuff.
2 to 30 megahertz.
Gotcha.
Now, just to let you know, the picture that we saw with the guy standing,
Yep.
the transmitter was 6 feet tall, about 10 feet long, and 6 feet deep, and it weighed 6 tons. When they took it off the ship, they had to cut the hull to remove it, right? And they actually had to put counterweights to make up for it, or the ship would have tilted. So I know for a fact that's, sorry, go ahead. Don, you had the question?
No, it's some other noise going on.
Okay.
No, but you must have heard my mind thinking. So it was a kilowatt output. Just out of curiosity, what was the finals?
What was the what?
What were the final tubes?
I don't remember the name, but I know they were about this big and about like that. And when I had it going, they were wet, white hot.
Were they ceramic?
No, they were glass tubes.
So something like 8873 or 813s or something
No,
like
they
that.
were this big
Bigger, yeah.
and about that tall. And I mean, you had a little window and you could see them. And
Warming up your room.
you had two settings, low power or high power. Low power was 300 watts. High power was 1,000. I've actually pegged it at about, I broke the needle on one of them. I think I was doing about 1,200.
That was output, right?
Yeah, output. Now this one here, the one on the back antenna with the ERC 32s that I showed you, we had 3 of them. Their maximum output was 500 watts. But when you're at sea, I mean, 1,000 watts, man, you're going pretty far. There was one other transmitter that got put in later on. It's called an ad-libs transmitter. This transmitter was used by the operations room in here. It consolidated all the sensor array, communications, and everything else on a plotting table. So the sonar, the electronic warfare, the radar, and We had a variable depth sonar here at the back. That all that information went in to the operations room. They could plot it electronically on this plotting table, but the transmitter was used to send all that data in between ships in the squadron. So any one of the ships could see what we had on our plot, we could see what they had on their plots. And that transmitter was capable of 1,500 watts. And it was in our spaces because it was a transmitter. So if we needed it to do a phone patch, we could access it.
Right.
Any further questions?
Any other questions, Brian? Okay.
Oh, you're muted.
Yeah, I was going to say no questions from me.
Okay.
I hope it was interesting.
Oh yeah, it was a very interesting pier. We've got about 35 minutes, which is fine. We don't we got a good feel for antennas and equipment and that sort of stuff on the Restigouche class. So yeah. Okay. Let's leave it at that. I've got the recording going, which I'll now I'll turn off in a moment. I just wanted to say thank you, Pierre, for the presentation. Very, very interesting. I found it very interesting when you told me a bunch of this stuff the first time around. The second time around, I found it really interesting too. Okay, thanks once again, Pierre.
Oh, you're most welcome.
Okay, I've stopped that. Okay.